So essentially, Sam, do you want to explain what you wanted to do?
Well, I wanted to talk about a bit towards these mechanisms that are being proposed to explain near-death experiences and the studies that tell us about brain function during cardiac arrest, during other sorts of conditions where these experiences are being had. I, of course, don't have a degree in any sort of neuroscience or anything because I'm still like a high school student. But I certainly am interested on evaluating this and see, because, for example, there have been a lot of claims that, for example, near-death experiences could be explained by some sort of residual brain activity. The most commonly cited study is that of Sonny Danani, which he posted a retraction of, and that of Dr. Jim Borgigan there in the University of Michigan. So we can talk about this a bit.
Mm-hmm.
And what you're
you
going
also
to
wanted to touch upon as well Pascal's Medium article on the surviving death series. Is that right?
Yeah, well, we can touch that. Yeah, absolutely. I would like to, because, for example, there are some things about the Pam Reynolds case we should discuss with, although I am pretty sure that we are going to, you and me, Darren, and if Pascal wants to join too, or anyone who wants to join, to talk about the Pam Reynolds case. I think it would be really interesting to clarify, because it seems like there's a lot of, unfortunately, misconceptions about the case. There, of course, are people who still claim that, for example, Kevin Williams still says that her experiences occurred at the time where she was in cardiac arrest. They did not. Obviously, they occurred while she was on deep anesthetics. So there's been a lot of debate around that case, and we can talk about that.
Because you kind of already specified some components of it, or should we leave it?
Yeah, should we let's leave the Pam Reynolds case until to that other video. I don't know if Pascal, if you wanted to come along to that one as well. We're just kind of loosely talking about what we could possibly do. But if you're interested, you can come along to that when we plan it. But for now, Sam, where do you want to begin with us?
Well, firstly, I want to talk about these this thing that has been going on for quite a while, about residual activity in the brain that could plausibly account for some of these experiences.
So this is the explanation, just to clarify, that near-death experiences could be explained, although sometimes there may be registrable flat EEG readings, which there are cases of that. Even if that was the case, there could still be this minuscule residual activity that's not measurable by the EEG that could account for these experiences. Is that about right?
About this residual argument, I think this has been touched quite a lot ever since the 80s, when Dr. Michael Sabon published his book talking about vertical experiences, these, which I really think are more specifically divided into a sub-phenomena of near-death experiences, because they are part of the phenomenology of near-death experiences, but are more like a sub-phenomena because they are only reported in a certain part of near-death experiences, not in all of them. Vertical perception is, of course, important. There has been a lot of debate about that too.
Yeah, and I certainly think that vertical perception in near-death experiences are kind of the turning point that make them objectively verifiable as phenomena. Because if I've often said, if near-death experiences were purely subjective, I wouldn't really have much interest in them, because I could never show them to be anything more than just in the mind of people.
Yeah. There's another type known as Pickendarien experiences. Dr. Evan Alexander published about that. Those are kind of harder to verify objectively, although there are parts where the physicians reported they're credible witnesses to that.
And do you want to briefly explain what Pickendarien experiences are?
Well, Pickendarien experiences are not a phenomena, are not just like exclusive to near-death experiences. Ian Stevenson has reported many of them. Deathbed visions, apparitions, all those kinds of phenomena. They report some Pickendarien experiences. I recently watched a video of Dr. Ian Stevenson from the Theosophical Society in America. And he talks about a case described to them, which appears also. So the Spicenderian term comes from a book from the 1880s, I think, which describes the surprise of explorers at finding that across the Darien, which actually is located in my country.
Yeah.
um,
The Darien, where is that exactly?
it's on the center north of the country. It goes all the way to through Panama too.
Yeah, because they ended up just looking over the Atlantic. That was the point, wasn't it? Instead of seeing the continent in front of them, which they were expecting. So it's just a weird roundabout way of coming to, to describing this experience of something which is seeing something which is unexpected, and like, let's say, a near-death experience from that. It's quite poetic. But yeah, so in this specific case, is seeing a dead person which you don't know was dead at the time, right?
There has been some debate about this, including by Dr. Gerald Burley, but I really think that while he does make some interesting articles, some interesting topics, although you can really sometimes feel the bias, unfortunately.
Well, before we get onto that, let's stick with the residual brain activity argument first, because that's where we wanted to begin. Pascal is your neurologist expert here, more so than us anyway.
Yeah.
So, do you have which questions did you want to pose to Pascal?
Well, okay, right, yeah. If there's a specific question,
or if you want to clarify first, Pascal.
Well, I just think, just to sort of begin with, I mean, I think it's probably useful to not use the word residual. I think that maybe skews it a little from the get-go, because that's been the word sort of used pre these very sort of telling studies of like the neurobiological activity at the point of death, like, because it's the idea that, the brain, when you have a heart attack, after 20-30 seconds, oxygen is significantly reduced in the brain to the extent that it can't sustain the activity of it, and so the EEG is apparently flat. But then, maybe there's some deeper activity which the EEG isn't picking up, because it only really picks up cortical activity, and therefore it's residual, and therefore that might be in itself sufficient to give rise to something like the near-death experience. So obviously with that, it's obviously the question of, well, even if there is residual activity, it's not going to be sufficient enough and not going to be organized enough. This very, very critical kind of quality of brain activity, which is necessary, according to neuroscientific view, in order to create conscious experience alone, let alone the kind of depth of conscious experiences and richness of conscious experience that you have in a near-death state. But while that seems paradoxical, there seems that, these studies, like you mentioned earlier, Gimo Borjigin's lab, including a recent one by Dean, the same lab, showing in rats, when you experimentally induce death in rats, and you measure all the different releases of an array of different neurotransmitters and neuromodulators and EEG activity, there is a very, very significant sort of almost program of activity which is triggered. And that involves, and this is, there's certain neurotransmitters which are released almost effective immediately, like, if I remember specifically, like dopamine and GABA, I believe that's right, like almost effective immediately. And then just a host of other monoamines like noradrenaline, serotonin, and then glutamate, the other excitatory transmitter, but that's just the main ones of just a veritable host of them that they actually measured over a very, very long period of minutes. And if you look at serotonin, which I think is the most interesting one, because it may well, I think it's possible that many of these neurotransmitters differentially contribute to different dimensions of the phenomenology of the near-death state. But if you look at serotonin, it's most interesting because ultimately the near-death experience is this, well, near-death experiences are so heterogeneous that it's hard to just call them, NDEs misleading, because there's such a spectrum of them, and even if you talk about the pieces of the phenomenology which is most common, I think that's misleading as to what the NDE really can be at its most deep, because the commonest ones are probably going to be the shallowest ones, actually. So that's, if you're thinking about deeper near-death experiences, maybe much more critical brain damage, longer amount of time, coma, etc., then basically what they have is a projection into an entirely new realm. And that is ultimately what serotonergic psychedelic drugs do. So those psychedelics which act on the serotonin system. So if you look at serotonin, at least, regardless of whether or not serotonin is actually psychedelic in action or not, which is contentious, that's actually released. It's just stupid how much it's released, and as reported in this paper, about 250 times the baseline levels at about 6 to 7 minutes in, I think. Yeah, so there's that. That's as a kind of preamble, if you want to say anything on that.
Well, yeah, I have quite a lot of questions because, for example, you made a point about serotonin. I don't really know about the effects of serotonin, so maybe I can ask you about some of those effects of serotonin. And there's, of course, the other neurotransmitter theories that have been put forward. For example, one is dimethyltryptamine. This was put forward by Dr. Rick Strassman's
Dimethyltryptamine.
DMT to most commonly known.
Yeah.
And there's the other one by Dr. Carl Jansen, which is ketamine. Yeah. Because it is also said that in these stressful situations for the brain, that ketamine is released. I have not really seen too much work about ketamine, so I'm not sure about that. I think that DMT is pretty much discreditable because, for example, Rick Strassman, I think, has retracted from his DMT theory for near-death experiences.
To add another kind of study to that level, I remember sending it to you, Pascal. I don't know if you had a chance to look at it, from Dr. Bruce Grayson and I think it was Charlotte Martial or something like that.
Yeah, for sure. It's one of my favorite studies. Yeah, no, I did know about it. Yeah, but then you did send it to me afterward. But yeah, it's an absolutely fascinating study. So basically, it was a semantic analysis where they looked at thousands of reports of different drugs uploaded on Erowid and compared them to, hundreds of near-death experience reports, and found that, I mean, it's somewhat better than using questionnaires in certain ways, and also has advantages over qualitative analyses, which are perhaps more subjective. But then with qualitative analysis, you have a human mind, the most complex computer on the planet, potentially the universe, to kind of work these things out. And with these kind of cruder algorithmic analyses, it will give you some insight. I think it was extremely insightful how they found through that a kind of spectrum of all the different drugs, and against, as a function, of how similar they are to near-death experiences. And because the output kind of makes sense. Ketamine was top, and then interestingly, it was salvia divinorum, which is a Mexican shamanic herb, kind of just below that. And then just below that, it was basically all the serotonin acting drugs, or similarly monoamine acting drugs, including like dopamine. And all of those were kind of sort of similar level, but the ketamine was actually pretty, interestingly higher. And so that was pretty good for Janssen. And his idea, obviously, it's a ketamine model. So if you look at other drugs like DMT as a model, DMT is endogenous, and so it may well be DMT itself. Whereas with ketamine, there is no ketamine in the body, but of course we've got the receptor, which is the Nmda receptor. And what's interesting about that receptor actually is it's actually kind of like, I mean, you can refer to substances as promiscuous in the sense that they attach to and activate multiple receptors. But I think the NMDA receptor is actually quite a promiscuous receptor, because there's lots of things in the body which do actually bind to it, and basically would mean that are other candidates for this ketamine-like model. And the reason why ketamine looks like a near-death experience is because these substances could be released at the point of death, basically doing the same downstream action thing.
Yeah, so not necessarily ketamine itself, but a drug that also binds to the receptors and causes the same reaction.
Exactly. Yeah.
Yeah.
And the out-of-body experience is one of the commonest, if not the commonest, experience with near-death experiences, because, like I said, like there's a spectrum of severity and depth, and so most of them are going to be shallower. And then, you know, the OBE is typically like the first thing that happens, so that's going to be the commonest. And ketamine is pretty much, out of all drugs, the most reliable one to induce an out-of-body experience. So that's just one but key reason why I think they overlap. But I think there are interestingly other pieces of the experience with ketamine and near-death experience which overlap, like the kind of tunnel effect. I mean, the kind of idea of a K-hole, and if there is a visual kind of component to that, it could look akin to that. And, you know, but then it's really difficult. I don't think you can neurochemically model the light at the end of the tunnel effect with near-death experiences, with drugs, because, you know, I am pretty interested, even not as a kind of wholehearted reductionist. I am interested in Blackmore's idea of the hyperexcitable optic tract at the point of death and oxygen deprivation, which creates that impression. But there's a similar kind of mirror with the K-hole, and the sort of sense of oblivion and abyss, or rather void type state, which can happen in near-death experiences and is described in, like, you know, other religious texts, but, you know, Tibetan texts and stuff. And the sense of encountering someone who died, who is dead. You know, that's actually, I mean, my research with DMT, it's not common, whereas that is very common in near-death experiences, but it is much more common with ketamine, I think, interestingly.
Yeah, I actually have seen a lot about these ketamine work. For example, Steven Novella, in his Skeptic's Guide to the Universe 10 years ago, actually has made the argument from ketamine. And of course, we also see a lot of debate still on DMT. For example, I have debated a bit with people in the comment section of, well, that's a thing these days. Yeah, you debate with people in YouTube comment sections. Because there was this guy called Holy Kool-Aid. Yes, certainly, because I unfortunately have encountered people who are not really don't really, there's a lot of comments about DMT being released at the point of death. And actually, Rick Strassman was not the one who was the one who put forward this argument, like, most commonly. The one who put that argument, like, mostly popularized was Joe Rogan. Apparently, I rarely watch his videos, because I think because he said, psychic phenomena has been proven to be complete BS. So I don't really, and I think he's kind of open-minded to that sense. So I don't really know if I can take him seriously. But yeah, Rick Strassman seriously has seen about that. And I recently have seen an article which compares the effects of DMT with people who report these near-death experiences. Yeah. Although they have some similarities, they are quite different from the actual experiences that these people have. No two near-death experiences are going to be the same, but they have universal factors. I mean, Evan Alexander's near-death experiences during his coma from meningitis have these going through other realm and everything like that, flying on a giant, I don't know, as he described it, on a butterfly with her deceased biological sister, which she didn't know, which classifies also as a Picandarian experience.
Mm-hmm.
And
well, can I jump in there, or have you got?
I've seen a lot of these DMT stuff, but maybe you're not knowledgeable about how DMT, no, not DMT, ketamine works, and in what situations does this work? Because I don't know, for example, how well it works. And that also goes for other arguments such as hypoxia. Although I think that pretty much has been discredited by now. Although the point that is currently being made is that, well, it's the release of neurotransmitters.
Well, the important thing to remember there is that if you meant like the kind of hypoxia theory has been discredited, it hasn't been discredited. It's just that it's just exceptionally simplified and oversimplified, because that is, of course, you can have different means, etiologies of death. You know, like with Ibn Alexander, you know, he had bacterial meningoencephalitis, and so it kind of deactivated his cortex. You know, so ultimately it is. I mean, it's not as straightforward as that. You know, his brain wasn't receiving the necessary, you know, nutrients and oxygen, but, you know, ultimately that was basically what was happening, just through a different path of hypoxia from like cardiac arrest or other, like, you know, systemic injury, etc. But basically the release of these transmitters is not a separate phenomenon. The fact is it's the convergent effect from the trigger of cardiovascular cessation, right? So it's still the hypoxic effect which causes this to happen, because that's the way that the brain understands that it's dying, and therefore triggers all the necessary, you know, factors to release these transmitters. You know what I mean?
I was wondering as well, Pascal, if you could just briefly give an idea of the of Blackmore's theory. I can't remember what it was, but of the tunnel sensation.
Yeah, sure. I mean, it's really interesting. I mean, she doesn't really go far enough, really. She just says that, well, basically, yeah, it's hypoxia, and the fact that the inhibitory neurons are somewhat more sensitive to excitatory neurons. Those inhibitory networks would die sooner, which means for overexcitation of the brain, which causes this kind of, well, for one thing, it causes glutamatergic excitotoxicity, which then that itself, leading back to what we were saying before, requires the release of protective mechanisms in the brain, like ketamine-like chemicals, because we know ketamine is extremely potent at causing protection of neurons in the sense, in this context of lack of oxygen or excess glutamate, etc. But it also, so this hypoxia also, and this lack of stabilization between inhibition and excitation, means that there's hyperexcitability by over, you know, stimulation of the neurons in the optic tract, and it will start from the fovea, which is the middle, outward to the peripheries, causing this illusion of, because it's expanding outward, it causes this natural illusion. And because of the fact that it constitutes your entire visual field, because it is your retina and your optic tract, this growing pinpoint of light, which gives the impression that you're moving toward it. Now, I think that's really interesting, but the kinetic thing, it makes sense logically, but for instance, in DMT experiences and stuff, you can also have this impression of movement from here elsewhere, and that could also be and you don't get the tunnel light at the end of the tunnel.
Would that theory account for the experience of an actual three-dimensional tunnel, as opposed to just like an illusion of light moving towards you? Because it often is described as a legitimate three-dimensional tunnel, like, you know, a building, as opposed to like the narrow. Many people that describe Susan Blackmore series say that she's talking about tunnel vision, where the outsides of your retinas begin to decay or whatever, and it creates this kind of this field, this pinpoint of tunnel vision. And whereas the phenomenology reported by near-death experiences are
near-deathers, I like that.
Near-deathers.
Yeah.
See, sometimes you come up with good names just by mistake. Instead of having actual tunnel vision, it is a three-dimensional tunnel environment. So, I mean, I don't know. Yeah.
No, totally. Like, that's what I meant earlier when I said that she doesn't go far enough, because it's simplistic and she doesn't even like address it. I mean, so yeah. I mean, when I acknowledge that, as I'm, you know, having doubts about her theory, but then there is really good evidence as well from Blanky, 2000, so there's multiple papers on it. And there's one particular one where he talks, because he's a neurologist, and he sees that post-cardiac arrest, people who survive, but have still had lack of oxygen to the brain and obviously the optic tract, regardless if they had NDEs. On neurological examination afterward, they do have evidence of hypoxia in the optic tract, which is exactly what you'd imagine to see, with substantiating Blackmore's theory. But in terms of what you said, and I totally agree with you, Darren, and it's weird that I haven't really heard much of that discussion about that, because it's quite obvious. So, but it's maybe because it's hard to understand why. I think, obviously, because that's my whole thesis, is finding well, it's not just the correlations of psychedelic and near-death experiences, but how it's just very instructive, but not totally explicatory, to think of near-death experiences as endogenous psychedelic experiences. Because the thing is with psychedelic, I mean, what the word means etymologically is mind revealing or soul manifesting. So so the thing is, there's all this debate about what is it that causes a near-death experience in the brain, you know, and you kind of simplify it, or is it ketamine, or is it DMT, blah, blah, blah. But there's so much happening in the brain at death, it's mind-boggling, and it's just, it is silly to think that you can just throw all that out of the bathwater, and just kind of describe to a survivalist thing. I mean, you have to take note of it, but you also need to be open-minded that, you know, even if we have all of these correlations, we don't know enough about the, you know, the metaphysics of everything. So the thing is, endogenous psychedelic-like chemicals are going to be part of that process, including hypoxia, which will create and trigger things like, because other areas of the brain which are sensitive include like the medial temporal lobe, the amygdala, the hippocampus, that can induce, you know, out-body experiences, life reviews, potentially things like that, but also the hypoxia in the optic tract, like we just said. So in explaining the fact that no one ever well, it does certainly happen. There's some people just see like a light at the end of the tunnel, at the end of kind of, you know, blackness, and expands, and there isn't a kind of richer phenomenology around it, but often there is. And I think the reason for that is because there is basically the synthesis of all this activity happening together. So when you have the light at the end of the tunnel from the optic tract, and you have psychedelic, you know, activity going on in your brain, you see, this is the reason why people say the word tunnel after, post hoc, you know, when they're describing the experience. But, you know, the subconscious is still percolating a kind of vocabulary to understand whatever stimulus is coming their way in this altered state. And so when tunnel comes to mind, it will, just like in psychedelic experiences, when you have a certain stimulus and a trigger, it then causes a cascade of imagery which your mind-brain complex is associated with that stimulus, and creates hallucinations around that. So that's precisely what's happening. You see the light, make the association of tunnel, there's serotonin flooding your blood brain, maybe DMT, you know, ketamine's also psychedelic, very psychedelic, and you create this narrative of it being like a tunnel, and whatever tunnels mean to you. It could be a brick tunnel, it could be like a metal tunnel, it could be, you know, like an underground tunnel, a cave, whatever.
Yeah, well, let me just weigh in there for
yeah.
Let me just weigh in a bit. I mean, I do agree to some extent that hypoxia has not really been discredited as an explanation. But I mean, as a direct cause, I am not really sure, because hypoxia, as you mentioned, could be, I mean, hypoxia could lead to a release of endogenous substances in the brain, which could potentially cause these experiences. Now, these experiences do not only happen on conditions where hypoxia is not a common factor. Take, for example, those could be described as near-death experiences. I like to refer to them, I mean, because near-death experiences is a term that has been enshrined into the NDE literature to describe them. Sam Parnia, for example, prefers to refer to them as actual death experiences, because it has been commonly said that these experiences, well, they are actually happening when the person is, well, dead clinically in a way.
Yeah.
But for example, these experiences that happen, for example, these experiences happen in general anesthesia, for example. And I don't really know how hypoxia is a factor there, because oftentimes your brain is literally drugged to shut down someone. Because, for example, Dr. Bruce Grayson cites quite a number of studies where EEG rhythms and everything like that during general anesthesia showed like the gamma and type EEG rhythms, and they like lost some significant power, and they went like to lower frequencies, and they had like
high frequency but lower power.
Yes, basically, like general anesthesia basically drugs your brain to shut down to some extent, but near-death experiences are frozen. Now, we have to be careful because we don't really know. For example, there's the ketamine is used as an anesthetic. So, for example, when Dr. Rajat Party had his near-death experiences under general anesthesia, he at first thought, well, yeah, maybe what happened here is, did somebody put LSD or ketamine in my anesthesia? And no, he found it was not the case. So maybe the neurotransmitter theory could be applied there, for example. But I'm not sure so much about hypoxia, because blood still flows through your brain when you're in general anesthesia, and general anesthesia actually has the potential to shut down your brain to the level of the brainstem. That's why a lot of the time they have to hook you up to a machine to breathe automatically.
If I could just very briefly jump in, I think what Pascal was saying before about hypoxia is not that it's solely exclusively causal, that it's not hypoxia alone that causes these experiences, but it's hypoxia mixed with or synthesized with other triggers, psychedelic triggers that may. So hypoxia may, you know what I mean.
But as you mentioned, Darren, for example, I've seen quite some of research about this, and people who have hypoxic hallucinations often will do report like a tunnel vision. But the thing is that they are often able to like recognize the aspect of having their eyes deprived of oxygen or their system like shutting down that way. They're actually able to recognize that because they can still see around what's going on in their rooms or anywhere they're suffering from hypoxia.
Yeah, see that's what adds the extra layer. See, this is why I always say that near-death experiences that include veridical perception during a time when the brain is measurably not functioning to the level that you would associate it with consciousness is that I could very, very easily say that, hypoxia mixed with ketamine effects and other various drugs could easily cause, I could see that hypoxia and ketamine could easily cause a three-dimensional tunnel hallucination. And without that objective verifiable aspect, I could very easily, take everything Pascal's saying and believe 100% that it's all in the mind due to the amount of chemicals released at death plus hypoxia. I could completely understand that. But when you have the veridical perception that takes place, especially those that take place maybe even when the brain is still functioning during CPR, for instance, when the brain's getting enough oxygen, but the the perception takes place in a room, a long distance away, relatively speaking, to the physical body. That kind of additional level of objectivity takes me away from thinking that it is purely. There are certainly aspects to the near-death experience which are pharmaceutically based, if that's the right word, that are due to chemicals.
Yes, I understand that, Darren, because, for example, recently I've been evaluating various of the veridical perception cases, and I think that the one that is, for example, you mentioned something, well, even when the brain is functioning, but according to some medical statistics, during cardiac anesthesia, it's more when anesthesia awareness is reported, which has been put forward as an explanation for near-death experiences, which I don't personally subscribe to, because we have observed the phenomenology of anesthesia awareness in these patients. And for example, the Al Sullivan case, which I think is a case that has a lot of evidential value, the surgeon flapping his arms and everything. Well, you can say, well, maybe his brain was still functioning. But the thing is, he observed something which even his working brain could not have caught because his eyes were taped shut. he was behind a surgical drape, and moving your arms to point things to your assistants does not make any sound, as far as I know. And you have the other sounds in the room. And then you have, for example, the other case of, I think I like this case very much, is the near-death experience of Michaela Roser from Homer City, Pennsylvania. She had this experience. Yeah, she had a car crash, right? And well, she had a cardiac arrest and everything like that. She went to the hospital. She had to be operated for a blood clot in her brain. She had to go to neurosurgery. The thing is that Michaela had an out-of-body experience. She saw herself in the operating room, but she didn't really talk about what she saw in the operating room. She just saw her body lying there in the operating room. What she describes is this near-death experience where she saw her mother, her two grandmothers, and her father in the hospital cafeteria smoking a cigarette, when that was not a behavior, when that was not really a behavior that was common to them, because her grandmothers would never ever smoke a cigarette. And so this surprised her. And then she asked this to her mother, who was called Nmda Receptor, and she was like, how did she know about this? There's no way that you would know about that unless you were there. And there's an interview that talks about that. It is impossible to know. It is impossible to know if her brain was functioning or not at this time. The point is, it's something that, but again, I would like to emphasize that I think that these vertical perceptions are more like a sub-phenomena, or just like an associated phenomena with near-death experiences, which we could call it more rather like.
Yeah, I mean, the near-death experience is a whole. It's the whole thing.
Extrasensory perception.
Yeah.
Extrasensory perception, because extrasensory perception and whatnot, these happens even in conditions where you're not near death. Near-death experiences don't happen in conditions where you're near death. People who fall off cliffs, I mean, this has been reported by Bruce Grayson. They fall off the cliffs and they have these blissful near-death experiences. These are near-death experiences. I will not from now on refer to cardiac arrest and general anesthesia as actual death experiences.
Well, the thing is, but we've gone through like a lot of different content, and I'm trying to like keep track of the different strands of it. But this last one, at least, the whole semantics of what to call them, I think actual death experiences, I know it makes sense, but I still think it's a misnomer, because the thing is, you need to be very clear. If you're going to be scientific about everything, you need to be using scientific definition terminology, and death itself is very well defined. Well, it's attempted to be very well defined, like biological phenomenon. And the thing is, it's by definition is irreversible. So if you have an actual death experience, there's no one's going to hear about it. So there's not a thing that you can talk about in this context. The thing is, it's useful to refer to near-death experiences as near-death experiences, like classical near-death experiences where the body is significantly impaired. If you had cardiac arrest, if you're in coma, that's a classic near-death experience. And it may well entail having a few minutes of total brain oxygen deprivation, but that could be, that's clinical death. You could be called by a doctor as clinically dead, but then you revive. So it's not actual death. It is the prototype of the near-death experience. And the ones that you're talking about in terms of falling off a cliff and things like that, basically fear-death experiences. You almost hit by a car, fall off a cliff, etc. Fear-death experiences, where meaning that there could very well be subtle neurological things happening. And there's a really interesting paper called what's it called? I can't remember now exactly, but it still basically refers to how if there is activity in the brain that happens at death, to protect it because of the inextricable relationship of the mind and brain and the predictive kind of nature of the brain. There's also, even in fear death scenarios, there is going to be, and there may well be opportunity for the brain to release certain factors, etc., prior to any insult to it, because it's basically anticipatory protective mechanisms happening. So there could be neural effects happening in fear death.
So let me just wait.
Psychological things happening as well. And then
Let me
there's
weigh in.
near-death, and then there's near-death-like, just to complete the spectrum. Sorry to go on here. The near-death-like experiences, which basically anything that kind of isn't there's no death context to it. You're meditating, deep meditative experiences, you're having hypnosis, you're in hypnagogic experiences before sleep, during sleep, and REM type sleep. And of course neurochemical models of like taking psychedelics and stuff, that's near-death-like, which can basically produce, as Charlotte Marshall, you mentioned before, who did that study, that semantic study with Grayson, also did another great study comparing these near-death-like experiences to classic near-death experiences, only using the near-death experience scale, which is really important to stress, but found that they were basically statistically the same. But I would presume very much so that if you, and that's a lot of what my PhD actually is if you look at the content of it, the nuanced content of it, those experiences won't be phenomenologically indistinguishable, and they would actually be quite different. But yeah.
If I might just add a very brief thing about sorry, Sam, just a thing that's important to cover on the fear-death experience. Something that always interests me about relating that to a materialist model is that somehow expectation is playing a role and interacting with matter to create that response. Because if we were looking at that from a purely material reductionist point of view, you'd have to have some sort of reaction. Say if you're falling off a cliff, it'd have to be triggered by the fast motion or something, as opposed to the person actually expecting that they're about to die. Because in a reductionist model, that expectation of being close to death shouldn't interfere with the neurochemical makeup of the brain. So consciousness shouldn't be able to affect matter.
Yes.
Well, how
Aaron, I think that because I think, for example, that Dr. Bruce Grayson has actually evaluated recently this idea. Well, these people are expecting. Okay, so but let me just change a bit things here. There are certain aspects of near-death experiences, and here are we speaking about near-death experiences, not like extrasensory perception that it's experienced during these experiences. For example, you would not probably expect seeing a person you didn't know was dead, or you didn't know at all in your experience. Well, because you were not expecting to see them, obviously. And Dr. Bruce Grayson has also analyzed the reports of people who see dead deceased relatives in their near-death experiences. And even sometimes they see deceased relatives who they really did not have too much of a connection, or that they didn't expect to see. But certainly there are some things that could be, certainly there are things that could modulate in some way your experience expectation. This is the problem of the social cultural things that we see in near-death experiences, because apparently, I have not really looked into that. People, for example, in India will report seeing one of the Hindu gods, although I think that what is most likely happening is that they are actually describing it in a metaphor that they can understand. I don't think it's necessarily, well, of course, that's just how I think it is. And well, Dr. Bruce Grayson is also a theory that he subscribes to, because we only have the words of the people who were experiencing these things to know if someone were the experience. We cannot really know if these people were seeing the Hindu gods or something like that. But I think that Dr. Bruce Grayson, I don't really,
I can completely understand that, because you're in that sense, you're talking about kind of your mental being. So if you want to think about it, your mental state kind of interfering with a more mental kind of state of being. So it's mental interfering with mental to create a metaphor of what you expect to see. But when it comes to things like fear-death experiences, you'd have to have your expectation, your belief that you're about to die would have to trigger and interact with the physical mechanisms in your brain.
Yeah. Well, I think the thing, I kind of got what you meant by saying that when you said that earlier, but it doesn't necessarily contradict the neurocentric kind of neuroscientific view, because we know that, I mean, neuroscientists don't have a problem with it, and like the idea of like placebo as well is a similar concept. But it seems like other people who try to kind of undermine the kind of neuroscientific views seem to think that it's incompatible, because the thing is, like neuroplasticity, for instance, is another one that they kind of use, because how can the mind change the brain if the brain generates the mind? But it's, you know, neuroscientists understand that it is this perpetual loop, and that, you know, there's nothing is. It's obviously a more philosophical debate as to if it, you know, mind-brain dualism, but, you know, if you do equate, you know, the mind to the brain, like then the brain, it's called saying that the mind changes the brain is the same as saying the brain changes the brain.
Yeah.
It makes sense.
Yeah, I see.
Yes.
I mean,
Although,
it's exactly the same as saying, like, oh, if it's, let's just take the same example of just feeling like you might be about to die. It's the same as like having a fight response. You know, it's like your body suddenly is drenched with adrenaline, because your body knows, your brain mind acknowledges on that more subconscious level, because obviously that is the level which we've evolved to use in those scenarios, otherwise we'd just die, to trigger these kinds of other chemicals. And adrenaline is one we all like understand, but it's a similar principle with these other chemicals which might produce more altered states of consciousness.
And I suppose at the end of it, though, you still have
actually some work about that.
You still have that brick wall of the hard problem to come up against, don't you? I suppose you would with any philosophical position.
That's always
really.
the brick wall we come across. Like we can have endless debates, and it's always the hard problem that we will always come back to.
We would always have this problem because under idealism, for example, which is a position I somewhat adhere to, there is no hard problem because everything is conscious or something like that. Again, I'm not really an expert in philosophy of mind, so I cannot really have an opinion in that matter. And yes, certainly, for example, recent literature in psychic phenomena, they say, you know, that these endogenous and these psychedelic drugs such as ketamine, DMT can actually, they are testing to see if these psychedelic substances could in some way generate an extrasensory perception or enhance some sort of psychic ability. Or
who are you referring to with that?
There are various studies recently in the Journal of Psychical Research, I think, which talk about how, and I think the University of Virginia, I think it's Kim Pemba, who studies these meditative states and everything, talks about how maybe these psychedelics could enhance psi or ESP, whatever you want to call it, experiences. But obviously there are, for example, the Eastern meditators have these meditation technique, these respiratory techniques, which reduces brain metabolism while they're meditating. And they can cause like these mind-boggling experiences. I don't know really how much this phenomenology is similar to near-death experiences, but according to Dr. Pim van Lommel, for example, near-death experiences also occur in meditative states, as you yourself have alluded to. So that's a thing.
Well, yeah. Well, I mean, again, this is always what I'm going to come back to, because this is my thesis. On pretty much every level of analysis, when you look at near-death experiences, it's very instructive to think of them as psychedelic in nature. And when I usually say that, and I appreciate that a lot of what I'm saying may look like I am coming from more like a neuroscientific, materialist perspective, but the thing is, I'm just always referring to the science before, opening my mind to other potentialities, but I hold them together simultaneously. So with psychedelic, because I'm just assuming I'm, relating that it's a drug, like an endogenous drug, like activity which happens in the brain, and that could lead people to think that it's reductionist, but it's not, because because it very much lends itself to a possibility of non-local perception and experiences. Because even if we're focusing on like veridical experiences and ESP as subsets of what happens in NDEs, as you say, and as I've done with my supervisor David Luke, and recently presented on with DMT, specifically in our field study, a main sort of protocol with that was looking to see if it does increase hits, correct, accurate hits on a video, on basically a precognitive video task while under the influence of DMT. And indeed, we did find that. So there is, we've recently generated some of that evidence that DMT, and that's obviously interesting because it is a main endogenous psychedelic in our body, maybe conducive to psi. I mean, that's a very simplified overview of what we did because it wasn't a blind condition. So basically we can't disentangle belief, which we already know is linked to psi capacity, and the compound itself. So there's that. But yeah, I mean, anthropologically, ever since anthropologists have been going to be studying indigenous communities who have various shamanic practices, many of which are using entheogenic, sacraments, and including ayahuasca, which includes DMT. They've all documented that, for instance, the ayahuasca vine, it has this compound, or a series of them, the beta carbolines, one of which, harmine, was originally called telepathy. Just as an example of how commonplace it was for the anthropologists to observe that these practices involved, precognitive visions or telepathic, encounters with, dead relatives, etc. So yeah, it's so when you say that these veridical experiences can happen when the brain is functional or non-functional, and regardless, it obviously points to some kind of, although it's anecdotal, there's plenty of anecdotal evidence. I just mentioned some experimental evidence. There's lots of experimental evidence that doesn't include psychedelics, but psi, I think there's good evidence for. So if that happens in the brain at the point of death, or in the stages where it is dying or is coming back online, regardless, it points to a undermining of the neurocentric view of consciousness. But that may well include psychedelic release, endogenous psychedelic release, which may be conducive to psi. But again, that's non-reductionistic, but because it's non-local. But of course, we would back to the thing that it could be temporary, right? It's sort of closer to meaning that maybe if mind is beyond brain, at least temporarily, maybe it's beyond brain non-temporarily, but we don't know.
Yeah, we certainly can make an inference there. We can say, well, yeah, the thing is that these psychedelics may well be like a release of the filters of the brain, releasing consciousness of something like that. There's some interesting work in psychedelics from English studies and Swiss studies, which show that when you take psychedelics, more richness in experience. There's more richness in experience and lower brain metabolism somewhat. And right. if like these psychedelic mechanisms for psi phenomena, I think it may plausibly be going on here. That kind of like adds someone. I think that it could possibly happen in a way. Yeah. But I don't really know much about these studies about psychedelics and psychic phenomena. But there are certainly there's certainly anecdotal stories too that are interesting. For example, I saw an interview with a guy where he says, "Well, I was having this DMT experience and I met this purple woman during my DMT experience, and she was my girlfriend. And I promised her that I would meet her again on another one of my DMT trips." And then he invited over a friend to his house to take DMT. And that guy said, "Hey, there's this purple woman here and they all know you here." And it's pretty interesting. So certainly it could be like a way to say, yeah, maybe it's a filter, or maybe these psychedelic releases could be some way that the brain is releasing its filters. But of course, I don't exactly know how the filter theory works.
So I suppose
the thing, I kind of, sorry, Darren.
I was just going to say, it seems the question is ultimately, are these psychedelic substances materially causal? Do they act as some sort of medium for richer conscious experience and lower brain filtration capabilities? That seems to be the two main possible explanations for the correlations between experience.
Well, if you remember, I put quite a large post after Bernardo Kastrup's talk with you, where he basically leveraged the recent, well, actually the thing is he didn't leverage the recent ones, he leveraged kind of cherry-picked one of the original, basically like the first 2016 paper by Imperial looking at the neural correlates of the psilocybin psychedelic experience, showing, as Sam mentioned earlier, that the overall gross global brain metabolism was lower, despite having obviously an exceptionally rich psychedelic experience. But that was very early in the advent of neuroimaging of psychedelics, which had never ever been done before. And later, it was very evident that it was the decrease in brain metabolism was selected for the default mode network, which is this very crucial sort of, it's like a kind of, if you look at the sensors of it in the brain, it's like the chassis almost, interestingly, and it sort of relates to autobiographical sense of self, mind wandering involving memory processes in the future and the past, but all self-referential, and it's that which is diminished. But it's an integrator hub of many disparately placed neural networks in the brain. So when that is decreased in activity, you have this kind of sense of ego loss and mystical experience, but you also have this really rich interconnection of neural networks, which are usually segregated from each other, under the process of desegregation, these networks, which corresponds to the equally, rich increase in psychedelic experience of phenomenology. So, I mean, we correspond, obviously the richness of the experience and all these nuanced, hyperconnective experiences, hyperconnective states of functional networks. And it's highly likely that, again, we've just got these correlations and the hard problem, yada, yada, but, it's very compelling that, that this is what's happening and this is what causes or mediates, what conditions the experience, whatever word you want to use. So obviously if these experiences, I just think he was just being oversimplifying things, and he needs to be more
so simply put, the decrease in the metabolism of the default mode network doesn't mean that the overall brain activity is less. It means that it's less compacted into that one area and more spread over the entire brain, which could account for this increased richness of experience. And apparently less activity, although it's only less activity localized in the default mode network, but it is spread a lot more and more connected elsewhere.
Less activity, more connection.
Yeah. Or less localized activity. Yeah. I see.
Yeah, I mean, the decreases, I mean, the thing is I'm talking about the Imperial studies in neuroimaging, but there's been, psychedelic neuroimaging in different places, and they have somewhat different, and using different psychedelics, and they have slightly different, results. And there's sometimes there are some areas which seem to be increased, but all, the decrease in activity is definitely in the default mode network. But I think at least in that first sort of seminal study, it was global, like in the sense that they didn't find any increase in activity.
Yes, we certainly have that. I mean, we can certainly, I don't really know too much about these kind of psychedelic imaging studies. I just know that Bernardo uses them a lot to make a case for idealism. He uses it.
Yeah, which he shouldn't really do. That's what basically
I know. Yeah.
I mean, he can. He just needs to he just needs to make sure that if you look at the, basically what I said and the nuances of the details of recent studies, like he just incorporates it into his framework of idealism. And if he thinks it's still compatible, then fair enough, he just needs to incorporate it.
Yes. So basically, we do have these, whether or not there is interconnectivity. I'm not really looked too much into these psychedelic studies. I just know offhand because, of course, as you say, Bernardo has oversimplified them in some way. The thing is here that while these people are taking these experiences, whether or not there is reduced brain metabolism, whatever, there is still brain activity going on. And what we see, for example, in these instances where near-death experiences are occurring is certainly not what you see on neuroimaging when someone is taking DMT, ketamine, and whatnot, and put into a neuroimaging machine. I mean, for example, well, we can make a lot of these theories about how near-death experiences could be caused in some way by psychedelics. The thing that I have with this is the extreme, of course, physiology that we have during cardiac arrest, during general anesthesia, that a lot of times simply I do not think it's conceivable that some sort of psychedelic experience could be occurring at this point.
So,
and we obviously have.
Sorry, Sam. Do you mean that
we obviously have?
Do you mean that the amount of activity in the brain isn't sufficient to correlate with the release of chemicals or something like that?
Well, look, we're having. I think that all of the years that we've had here, exploring near-death experiences, the experts, everything. Sam Parnier's 2002 study. They really are saying, I think these experiences are most likely happening not before or after, but during the period of cardiac arrest where these people have their heart stopped, right? And as you know, for example, you lose consciousness very quickly when there's no blood getting to your brain. And that's what's happening here in cardiac arrest, for example. And from 6.5 to 20 seconds, I think. And that's when the EEG electrodes, which are measuring cortical brain activity or whatnot, are the ones that are having a reduced level of activity based on all these studies that we're showing here. For example, Dr. Bruce Grayson recently, in his book, After, which he analyzes this possibility of a surge of neurological activity at the time of death. And he cites a study from 2017, which precisely analyzes people who have their heart stopped, who are in cardiac arrest, their EEGs at the time. And he found that, and what he says about that study is that even before these people had their heart stopped, they pretty much had a very reduced EEG activity somewhat, maybe because there's some changes in ischemic activity due to blood flow and everything like that, because obviously blood flow is a very important factor that you have when analyzing brain activity, whatever method you're using. Either it's fMRI, EEG, everything such as that. But of course, it's not the only factor, because obviously the EEG also measures activity when there's blood flow, such as general anesthesia, but your brain metabolism is pretty much reduced because your brain is drugged, as I already mentioned. Well, he found that there's no well-defined EEG activity, for example, in these patients after they had their heart stop. So that's when we have to get into right now about these surge of electrical activity in the brain at the time of death.
Mm-hmm.
And the point I was trying to make, Darren, about these is because, for example, I think that one of the reasons why I don't really find too compelling this idea that's DMT, for example, could be responsible in some way for these experiences is because, for example, after cardiac arrest, when someone regains consciousness after, they're usually confusional because, of course, they have a swollen brain. No matter how much blood you lost or for how long you lost it, your brain is swollen because, the blood has the nutrients that are necessary for you to be conscious in some way. And if it loses that, that's why that's where the so-called process of biological death begins. That's where the brain cells start to die. This is the chemical activity, which or something like that, I guess. But when these people regain, I don't really know. As Pascal mentioned, there is evidence that these people, there's evidence of hypoxia, and they have these swollen brains after they regain consciousness. But for example, we don't really find too much evidence that these people, for example, are having the hangover effects of DMT, for example. DMT has been reported to have hangover effects. So when people are resuscitated, for example, in Penny Sartori's study, two people that were shocked that they used the defibrillators on. They regained consciousness almost immediately, but they had like no hangover effects of DMT that is usually reported when people come out of DMT, because people would come out of these psychedelic experiences. They usually have this hangover from being through this. They have like snippets of hallucinations. You can call them that, snippets of hallucinations. We don't really see too much of this in near-death experiences. And in some way it makes sense, because as I said, these people, when they come back, you need blood in your brain for cells to live. Your brain is like swollen after you have a cardiac arrest and everything like that. So it is part of the reasons why I'm kind of doubtful. I don't discredit it at all, because it's certainly a possibility about these endogenous like psychedelics and neurotransmitters. But I think that is one of the main reasons why I don't think that, at least in the context of cardiac arrest and general anesthesia, that these people could have, that the psychedelic substances could plausibly account for at least in these two physiological conditions.
Well, it is interesting, the idea that if you were to have, I mean, it's different with like other psychedelics, let's say psilocybin, LSD, because these are like 6-8 hour experiences, and you'll be I mean, it's difficult to tell how much sort of receptor saturation there will be with the comparison with if it was released in the brain at death, and with if you were to just naturally take it. But I think at least with DMT it's interesting, because we know from the same lab as Dima Borjigan from 2019 that in rats, when there is experimental death, DMT is released directly from the cortex, but it's nowhere near as much as was previously found just a few years before in the same lab with as many other transmitters, including serotonin. So it may well be scale up in humans, but with DMT it may well be a component, but just a component, and many other factors integrated within that. But with DMT, it's like you've referred to as like the DMT flash sometimes, because it's very short-lived psychedelic, and that's probably because the brain has very good mechanisms for mopping it up because it's endogenous, compared to LSD, for instance, which is certainly not endogenous, has a bit of a bulky kind of structure to it, dissimilar from the exact serotonin receptor, and it actually kind of hooks. There's recent research showing that the molecule part of it, like the leg of it, kind of hooks into the receptor site and it stays there for ages. That's not the case for DMT, because it's in our body and it interacts with those receptors anyway. And so if it were to be, pardon?
Because the mechanism's already there to, as you say, mop it up.
Exactly. So I mean, the DMT is a kind of good candidate anyway, because it's you don't really have a near death unless it's a very protracted coma, with heart attack and other acute like disorders. Like it's usually going to be in the orders of minutes where you're kind of clinically dying temporarily and then you are revived, and that's similar to the order of minutes that the peak DMT experience happens, right? Even if you were to take a massive dose of it, which is going to be way more than the whatever is multiplication of the baseline levels that you have normally in your brain at the point of death. So so the thing is, it is interesting about the idea that why can people have near-death experiences for a few minutes and have this like transcendent, like mind-blowing experience, and then when they come back it's like completely they're here all again, like surely and I don't really like using the term hangover effects, because that's you refer to alcohol as like with that, and that's completely different drugs. But there is this afterglow, or it is just more of a protracted experience normally. But the thing is, if we're looking at substances which are released in the brain endogenously, then they're co-evolved with the nervous system since day dot, and so they're going to have all the metabolic machinery there ready to mop it up.
Yes, of course. I don't really know about that. I think the Borjigan study, though, you say that DMT and all of their endogenous substances are being released. For example, Penny Sartori made a study where she evaluated if near-death experiences could be caused by drugs given to people while they're recovering from cardiac arrest, including endorphins, which is commonly used after cardiac resuscitation. Well, people who were given these drugs were actually less likely to report any sort of
Yeah, but
experience.
that's completely different, isn't it? To like the administration of drugs, which aren't psychedelic. You're not going to administer psychedelic to someone who's dying. They're completely different to these drugs that I'm proposing, and well, these substances which I'm proposing might be released. Well, there is evidence that they're released in the brain at death. Like, you know, like you give morphine, you know, might give like antibiotics and things like that. You know, why it makes sense that giving these drugs are going to depress the spontaneous you know, report of near-death experiences. I think because you're interfering with the natural possible neural program which happens at the point of death. And there's also interesting studies which show that if you give naloxone, which is a opioid antagonist, which is given for like people having opioid overdoses, for instance. Well, there's a study, you know, showing that to people who are dying, when they come back and they actually report a near-death experience, which was originally blissful, was kind of most typical kind of near-death experiences, and then kind of coincident with the administration of naloxone, it became kind of like a dark, hellish experience, which is really fascinating. But you can't equate, you know, because Bruce Grayson did this in his book. Like, you can't equate the administered drugs, which are typically happen in hospital, you know, or palliative environments, to these potential substances being released in the brain. They're just different.
You have to talk about them as two separate.
I know
possible,
that. I was particularly addressing endorphins as a possible explanation, though. About these studies on brains, are these psychedelic endogenous substances found only in the brains of rats, for example? Because, for example, David Nichols notes that the pineal gland will have to produce a significant amount of DMT, at least in human brains, to cause a psychedelic experience somehow.
Yeah.
And for example, in humans, DMT is known to be happening in the pineal gland. I don't know really about neurotransmitters in the cerebral cortex, but certainly it's mostly found on the pineal gland, some sort of thing.
Well, it's not mostly found. That's not the case. So in the rats, so this same paper that found the increase in DMT in rats at death, the fact that there was very significant baseline levels of DMT in the actual cortical tissue, and it increased there regardless of if the rats had pineal glands surgically removed or not. And they found that the enzymes necessary, ADAC and NMDA, were high levels in the brain. Those two necessary enzymes for the synthesis of DMT, high levels in the actual brain and not very high in the peripheral tissues, which was originally thought to produce DMT, like the lungs and elsewhere. And in humans, it's been found that we've only found that DMT is in the cerebrospinal fluid, urine, you know, but that's an excretion, and at very, very low levels. So that was part of why Nichols was saying what he was saying, is like, oh, it's ridiculous to say that DMT has got anything to do with near-death experience, because it's just such infinitesimal amounts, and the order of time where you have a near-death experience, you know, and if it comes from the pineal gland, you know, even though there are the enzymes in the pineal gland for the synthesis of DMT, it would require something like requiring to synthesize a quarter or more of the pineal gland's mass of pure DMT in like the order of seconds, which is stupid. But the thing is, if you know, these same mechanisms, which as we have noted in the rats, are evolutionarily conserved in humans, and it's usually the case, at least this is Gmo, you know, what she sort of concluded, that things are kind of phylogenetically like elaborated on, rather than things taken away. So if rats have it, it's likely that we have it amongst many, many other things. yeah, that the brain, it's still possible that the brain may well act similarly as the rat and to have DMT released directly from it, but probably not in high levels. But maybe enough to at least condition the near-death experience amongst everything else.
Yeah, so essentially, certainly DMT can't be solely responsible because it's not enough of it.
Well, it's definitely not so. This is what I'll always come back to. Nothing is solely responsible for the near-death experience. As a sort of kind of, I think, outmoded sort of early near-death experience research trying to look for a simplified model, brain model. But it also, when you look at the phenomenology as well, Darren, right? It's like, if you look at the DMT experience and if you look at the near-death experience, which is another paper which Sam kind of alluded to earlier, which was done with the near-death experience questionnaire, they look the same just on the basis of the scale. But actually, if you look at the richer phenomenology, they're actually extremely different. So it's going to be, it may well have something to do with the near-death experience. Maybe, who knows? It allows for the kind of transition into, for the brain to model a whole new world, which, I'm not saying is purely within the brain, but, maybe mediating of that. And then, other things influence in different ways.
Yeah, certainly. I do understand, for example, well, yeah, maybe we can find these things on humans, such as the brain activity at the time of death, the surge of neuroelectrical activity at the time of death that could possibly account for these experiences. Because certainly mammalian brains are similar. Rats are mammals, as far as I know.
Exactly. Yeah,
we are mammals. That's right. But for example, we do certainly see differences in scale and in certain things, and we have some problems, for example, interpreting some of these studies. Take, for example, the study on the electrical activity in rats that go on cardiac arrest. These highly coherent yet low-powered activity that is found in rats. Apparently, Jim Borgigon was using EEG depth electrodes to analyze these.
Mm-hmm.
We certainly, obviously, we use SCOP EEG technology in humans, and we don't really find that. Then again, there are many older studies, but obviously there's one more recent from 2017, which I mentioned, from Lorraine Norton, which actually measures these EEG activity on humans that go into cardiac arrest.
What's the author called?
Let me search for it real quick. Dr. Bruce Grayson actually cited it, I think. The study is called Electroencephalographic Recordings During Withdrawal of Life-Sustaining Therapy Until 30 Minutes After Declaration of Death. This is a different study from Lorraine Norton. There's another one with a similar title from Sonny Danani, where he allegedly found some electrical activity, but he withdrew that because he withdrew his conclusions, and he concluded that the activity most likely was an artifact. But for example, these electroencephalographic recordings during withdrawal of life-sustaining therapy until 30 minutes after declaration of death is from 2017 in the Canadian Journal of Neurological Sciences.
How do you spell his surname?
Sorry, what?
It was Leonard Norbin or something.
Loretta Norton.
Oh, Norton. Right. I'm not sure I know that exact paper, but the thing is, there's actually I like continually come across them. Like the original ones I saw with Al Young and another one by Charla, but then I saw multiple ones sort of in obscure areas of the literaturescape showing the same thing. That during life support withdrawal, which is a different setting, which is more conducive to doing EEG activity, measurements in those kinds of conditions, they show that there is this surge of high frequency, the surge of high frequency activity, and some of which showing that it's in the gamma band, and can be analysed kind of reliably as that. Now that's different to the kind of claims of EEG being measured during other near-death, well, like actual near-death states, as opposed to those real death experiences or states in the life withdrawal studies, right? Because with cardiac arrest and etc., there you don't have EEG. I mean, there's very specific scenarios like with Pam Reynolds and stuff, because but that wasn't even. She had recordings, electrical evoked, auditory evoked recordings from the brainstem, but so there was at least some kind of residual sort of brainstem activity, but I don't actually think they had an EEG in that scenario. It's just
they did.
They were just looking at ERPs
in those kinds.
I believe so. I believe so.
Right.
In
well,
those kinds
yeah.
of,
So there was no brain activity in that sense. There's selective examples in those kind of things. But with the life withdrawal, that is interesting, because there's lots of that happening, because you need the measurements of the brain in order to make sure that you do have, what seems to be irreversible brain death, so you can legally remove the organs. And yeah, so you do have the surge, which does correspond to the rat models.
Yeah, we have the study you cited from Dr. Lakshmi Chawla, who's an anesthesiologist who actually measured this. Certainly, he observed that. I think it was in 2010 that he published this study. But for example, as far as I know, in Dr. Chawla's study, they didn't use like a standard encephalograms, but they used like some.
Yeah, the Bismuth. It's different. It's literally just like the equivalent to like a couple of electrodes on the frontal cortex.
Yes, they use like bispectral index, and these things are very vulnerable to like pollution, and it's prone to false readings.
Well, if that's the case, then why are they using them for extremely important, work? I mean, it's way more important than just thinking, oh, is there an afterlife? Is the brain, what activity is happening in the brain at, the time of death? Like you're talking about people potentially having conscious experiences when you're removing their organs. That's important. If you need to make sure that the bispectral index works, and if it works enough for people to accept to be using them for those conditions and settings, then why critique it when you're trying to make these other kind of possible conclusions?
What exactly do you mean by that, though?
Well, if good enough to be, if they're considered accurate enough to be used when removing organs from people who are potentially having perceptual experiences, then why are they not good enough to at least take somewhat seriously the possible conclusions that there is this gamma surge which happens at the point of brain death, rather than thinking of it as just as an artifact?
Because what we observed in Lakshmi Chawla's study is similar with what we observed in Dr. Nmda Nani's study, and that is that this surge of electrical activity happened quite at a time after a long time after the blood flow to the brain had stopped, long after these people had a cardiac arrest. I mean, Nmda Nani already concluded, yeah, this was an artifact. I had not heard from Dr. Lakshmi Chawla recently, but certainly, I don't know exactly how it's used, but I guess that these things are somewhat vulnerable to. I mean, this is not what I say. This is the opinion of people. Obviously, EEGs are very sensible to artifact pollution and everything like that.
Yeah,
I mean,
sorry.
And I understand the point you were making, because, for example, Stuart Hameroff interprets the surge of electrical activity as the soul leaving the body, and that's kind of a woo thing to think about. I mean, it's in my plausible book, but this sounds a lot like special pleading, so I don't really know. I don't really, but yeah, I mean, what certainly is found in Chawla's study, I don't think it has been really somewhat consistent because we see we have Dr. Lakmer-Chola. Certainly, this could be caused physiologically. I'm not denying that. But the thing is that these like two electrodes over here with the bispectral index, they are prone, so for example, to muscle twitching. And they're certainly, because during cardiac arrest, only your brain is non-functional and your body's pretty much still functional. Your muscles are still twitching. And apparently this bispectral index method of measuring brain activity is very prone to artifact pollution in these conditions. So I don't really know how to interpret Dr. Lakmer-Chola's study.
Mm-hmm.
And you also mentioned the Pam Reynolds case. Well, in this kinds of operations called standstill, where basically you have your heart stopped, it is true that these brainstem auditory evoked potentials, which measure activity directly from the brainstem, do register clicks, but they register these clicks during a period of burst suppression, for example. Burst suppression, this is at least during pharmacological burst suppression, there is nearly no like activity, EEG activity, because your brain has in the deepest anesthetic state. It pretty much like has, out of 10 seconds, 9 seconds is going to be flat EEG and one of a small surge during this period of time. So yes. And for example, there's other method that they use in the Pam Reynolds case. For example, somatosensory evoked potentials, which measure activity, I think, in like lower layers of the brain. I'm not really sure about that one. I'm going to have to look into that. But what is true is that during cardiac arrest, during the period of standstill, for example, the brainstem auditory evoked potentials do stop registering activity in the brainstem. So these viability of the brainstem only occurs in general anesthesia, but does not really occur during the period of standstill, i.e. when there's cardiac arrest. There's definitely no brainstem activity at that point, as far as I can tell. And we also have some other evidence from this, but I think that the most sophisticated evidence is of course from the brainstem recordings in this kind of operations, where there's definitely no brainstem function measurable by these BAEPs, at least during the time of cardiac arrest. But during resuscitation, for example, there is no pupil, your pupils are dilated, your eyes are not functioning, and that's a function that is controlled through the brainstem. You're not breathing, which is also a function that is related to the brainstem. You have no heartbeat, and your heartbeat in some way is modulated by the brainstem. And your gag reflexes is something that is also controlled in some way by the brainstem. And during resuscitation, we don't see that too much. We don't see that. That's why when they're trying to resuscitate a person, they put like these tubes inside. And this is partly the reason why I think that, because apparently, according to, even Stephen Novella, who's a neurologist and who is a skeptic and who has tried to somewhat debunk NDEs or something like that. I think he's too harsh in that sense.
Yeah.
He admits that, he certainly admits that without a brainstem, there cannot be any plausible electrical activity that could be responsible. For example, he analyzed the case of a lady of a young girl who had no brainstem function, but they still could detect some sort of electrical activity in the brain while she was in a coma. And he said, well, if the brainstem is not functioning, no matter how much activity you have in the cortex, it's effectively nothing. She's not aware of your own experience or anything like that.
Well, I don't know. Novella, I've got a problem with the doctors a lot of the time. maybe, yeah, I mean, and speaking to my scientist kind of colleagues and stuff, they understand where I'm coming from, because they do see, they're, even if they're academic, neurologists and things, and even Alexander, and I think neurosurgery is even like even more of an example of that, and even Alexander might come under that bracket as well. They don't have, they just don't have the way that they are as doctors. They don't have as specific, detailed, nuanced understanding of the mechanisms itself of, in this case, let's say the brain. So Novella, and he, there's very fast, especially really vanguard, theories of mechanisms of mind, of consciousness and relationship with the brain. They often not read up on, like, so even if there is no brainstem activity, but there may be activity elsewhere in the cortex, even if, and this is really groundbreaking, if there's some, theories of consciousness, information integration theory, which is Tononi's concept, there is some suggestion within that theoretical framework that even if you have no brain activity, you could still have conscious experience, which is absolutely fascinating. But then there are conditions kind of around that which would imply that possibility. But anyway, moving from that is, I mean, if we look at these, what was I going to say? The surges of activity that we see, there's very many examples in these life withdrawal scenarios of finding similar high frequency surge, at similar times. I mean, from like Al Young and Charles, I think it was around about, like, there was a delay, but then about like a couple to 3 minutes post total blood pressure loss, there's this surge which happens, and that can be interesting from the perspective of thinking that, when you have cardiac arrest and stuff, the kind of prototype of an NDE, and your brain is without EEG activity for several minutes, and yet these people are still having like veridical out-of-body experiences or other near-death experiences, although the latter you can't really pinpoint in time. But then given that this surge happens around the same time, that's quite compelling. And I think the idea of it being an artifact, I've already kind of mentioned why philosophically maybe you shouldn't think that that's too much of an issue, but at least from the analytical side, there are very many methods of extracting it as an artifact and increasing the likelihood that it's not an artifact. These muscle movements and rigor mortis and stuff, like, it's not that intractable with modern techniques, and the idea of it being a total reductionistic, the brain, the death surge, as it's kind of referred to, or death wave, it doesn't have to be a reductionist thing, which is always what I come back to as well, trying to synthesize these perspectives. It's interesting you bring up Hameroff, because I mean, although it's this sort of funny simplification to say that, I mean, in one interview that I saw him do, he said that in near-death experiences, and citing these kind of surge activities, your brain, your soul kind of leaks out of your brain. It's a kind of simplification, but he's got quite a technical understanding of the and his own kind of paradigm of mind-brain relationship involving quantum activity and microtubules, which is developed with Penrose. And so his kind of idea, to again kind of remember my reading of it and kind of simplify it, is that, I mean, I kind of see it as a kind of reverse of the Copenhagen interpretation of the collapse of the wave function, like when consciousness collapsed the wave. It's kind of the opposite, and he says that space-time geometry itself gives rise to conscious experience, and the way that space-time geometry is influenced by the quantum activity at the level of microtubules within neurons kind of gives rise to conscious experience. And so he's kind of equating, or corresponding, these high frequency surges on the macro brain level with these potential mechanisms happening on the microtubular level, but obviously diffusely throughout the brain and cortex.
Yeah, I understand, because, for example, Dr. Lahmir Chola has said, well, maybe this activity could plausibly be located in the brainstem rather than in the cortex. He has said that, actually.
Mm-hmm.
Although I don't really know about the other studies about life surges, because, for example, the study by Sonny Danani, which found these electrical activity, well, yeah, he concluded that these happened way too after people had no blood flow to the brain.
They what?
So,
they happen what?
way after these people had no blood flow to the brain, because obviously there is no blood getting to your brain when you're in cardiac arrest and things like that.
Unless you're undergoing CPR.
So,
What was that, Darren?
Unless they're undergoing CPR during the time.
Right.
no, not even CPR, because during CPR, using drugs and everything, the best you can get is
Low percentage of oxygen recovery.
It's like 30%. It's like 30% of your blood. So you require, apparently, according to neuroscientific opinion, you require a certain amount of blood to your brain for you to have any sort of physical conscious experience. We don't see that during cardiac arrest. For example, we don't see that during cardiopulmonary resuscitation, because only about 5 to 30%. 30% is at best using drugs and every methods. You don't really get to arouse consciousness, at least in the context of true cardiac arrest, because there are these instances where people have their blood pressure drop and they lose consciousness, but they're not in cardiac arrest. So they are erroneously shocked with a defibrillator or erroneously given CPR. So they feel like they are tearing their intestines apart, or they're breaking their ribs, or getting kicked by a horse, as is commonly described by people who have these who have been defibrillated in the past erroneously. But yeah, certainly. And apparently, if you use certain drugs, because, for example, in 2019 study, Parney apparently found one patient during prolonged CPR around 60 minutes, where they use the same kind of I think it was also a bispectral index to measure activity during CPR for these patients. And at a point, he saw like a surge of brain activity while resuscitating this patient during 45 to 60 minutes. And obviously, we come back to this point: how can we interpret these signals? Because it's certainly the case that during CPR, you are being moved. Your body's pretty much being moved, even if you're not conscious. Your body's pretty much alive, except your brain, I think. So there certainly could be some activity from the muscles that could make its way into that bispectral index. And it's why so many people find these, and there's actually some peer-reviewed studies which talk about the unreliability, for example, of these measurements of brain activity that the people are, including Chola's study, of which show that these bispectral indexes are very prone to pollution artifacts, and similar to that in Parney's study. Although, as you mentioned, they could be used reliably for organ donation and everything. Right? I don't know really about that. I have to search for some of that, because I think it might be interesting too. There certainly are some studies that say that maybe this is not really so reliable in certain physiological conditions, because donating an organ is not comparable really to a position where there is cardiac arrest and there is effectively no blood flow going to the brain. And during
Sorry,
organ
what was that last bit? Are you sort of saying, is this something you mentioned before, that because there's such a time sort of delay between total blood loss and then this surge of activity, that because there's no, is he saying the kind of the lack of blood flow to the brain couldn't support this electrical surge?
Yeah, according to some neurologists I've heard speak about this, but they still think, well, maybe these experiences could be happening after the fact, when the brain has been restarted. But yeah,
Well,
some of
well,
these
the thing is
people.
that, sorry.
But yeah, for example, Sonny Donati in his study concluded that this activity was likely an artifact because it occurred. He used standard electroencephalogram, I think. I'm going to have to review that again. Sonny Donati study. He found that the activity had stopped long after these people had no like blood flow to the brain, so that the activity was most likely an artifact. And
It started or stopped long after the loss of blood flow to the brain.
I mean, in Sonny Donati study, they found electrical activity in a human undergoing cardiac arrest in hospice, I think, I don't know. And this activity, according to the extraction letter, occurred long after the fact that the heart stopped, and they concluded, therefore, that this could be most likely an artifact. And not
so it wasn't like brain derived; it was like muscularly derived. It's because there was no blood flow in order to cause the activity.
Yeah.
Yeah. Well, I mean, at least remembering Charlotte and Ayong's paper, I think they kind of chalked it up to potassium currents from the loss of the receptor, loss of the membrane potential, and causing cortical spreading, cortical like depolarization. But that doesn't require. So there's like a leaking of an excess of the potassium ion currents. But that doesn't require, to my knowledge, it doesn't require blood flow because it's not an active metabolic like phenomenon in the brain. It's a kind of fallout from this lack of activity and brain degeneration, basically neuronal degeneration. So you don't need so it can still kind of give rise to this cortical spreading, which looks like high frequency EEG without actually having the actual metabolic support from blood flow. And another kind of interesting thing about that is that there's been another recent paper by Eddie Frexker showing that, I mean, he's already found, done loads of studies of DMT when in vitro and ex vivo, looking at DMT pre-treatment of these setups before ischemia and oxygen deprivation means that there's a protective effect, right, and less ischemic sort of indices afterward. But he's also found that with this similar cortical spreading depolarization effect, and DMT also mitigates that. So again, we've got this kind of symbiosis of the activity which happens kind of as a consequence of brain impairment at the point of death, and the effects of the other protective endogenous mechanisms, both of which may well contribute to the near-death phenomenology. So you could have cortical spreading, kind of gamma-like activity, and DMT kind of released as a protective mechanism against that, maybe simultaneously.
Yes. In the Pam Reynolds case, for example, they use neuroprotectors. That's how she was in burst suppression and the deepest anesthetic state. They use barbiturates, propofol, and everything like that. These alongside hypothermia protect your brain from like receiving damage. That's why people who undergo these operations can resist for so long. The lack of blood to the brain. That's because they use this barbiturate, propofol, and everything like that to protect the brain. But at the same time, while these barbiturates protect your brain, it also shuts down brain metabolism, as we see in general anesthesia and other conditions like that. That's why I think they still use this method a lot. And Dr. Robert Spetzler, for example, found that it's useful not only for these kind of standstill operations, but also for other kinds of operations. For example, a treatment of arteriovenous malformations in the cerebrum, and treating like endarterectomies in the carotid artery. I think it's, I don't know how to spell it correctly, carotid artery. They use that. So yeah, it certainly could be. I mean, some of the people that I've discussed with, and I talk about the Bojigan study, for example, with it, and when they concluded, yeah, I mean, the brainstem is out of the equation also too. So this activity may well be a calcium release. So we don't really know if we can interpret that as brain activity. So certainly.
Yeah. I mean, talking of brain blood loss and things, I'm getting a bit, I don't think I've eaten much dinner this evening. So is there, what kind of things might, because just in terms of potentially me having to wrap up and having to leave you guys, is there some like sort of specific things which will be an interesting thing to try to talk about conclusively, maybe, or that we haven't touched on, or that you wanted to
well,
chat about?
I would have liked to ask you about what you think is the evidential value of veridical perception in near-death and out-of-body states. For instance, whether the brain is registered to be active or not. Those that take place, say, of events non-local to the physical body, so in the next room or in the next country or whatever, which are third-party verified by professionals, doctors, and whoever else, and of those that take place, such as those in the Pam Reynolds case, where it seems that the events perceived can be tracked to the time when the brain was registering flat on an EEG. Just wondered what your thoughts are on the evidential value of that for, say, the survival hypothesis.
Yeah. Well, yeah, I mean, I kind of touched on it before, and I think it brings us closer to the survival hypothesis. But yeah, I mean, maybe that is sort of one of the best things we have at ever coming close to the survival hypothesis, because it is the best third person kind of, corroboratable, objective enough, thing that we can hone in on in order to suggest survival, other than going there ourselves, because everyone who has a near-death experience has proof enough for themselves, because it is a first-person experience. But if you can't make it third person, then it means that it's not proof for anyone else, just for them. But the evidential value of veridical OBEs and other side effects with NDEs, it is obviously one, and it makes sense for you to kind of want to come back to that, because it is the most compelling. But yeah, I mean, I think so there is the experimental evidence, including with psychedelics, and there's been a long history of that, and it's getting more rigorous now. But yeah, and the sheer quantity of the qualitative, reports, case studies, is extremely compelling, and I think just the richness, the specificity of it, and the consistency, regardless of them being anecdotal, you need to really incorporate them into your kind of framework for thinking about this stuff. And in terms of it, there being some suggestion in a lot of the cases that the timing of it seems to match with when the brain would appear to be totally deactivated, and that's why these OBEs, veridical OBEs, are particularly good at that, because you can make those correlations in time. There's obviously what we already spoke about how there's only the notional idea from the history of neurology that that after 30 seconds the brain has less activity, but there may well be very significant activity which happens very soon, and then maybe neuroelectric activity which happens after, and those themselves could correspond to the out-body experience at the same time. But then you know, and again, like we already mentioned, that, you know, if there's endogenous psychedelics, then that may give rise to these experiences because they've already been associated with the extrasensory perception. But what's interesting is that they could happen, you know, even if you were to have, even if you, let's just paint a portrait of you know, the brain dying and then declining in activity and then being having total cessation of activity and then, you know, creeping up back in activity after revival in a sort of this pastiche near-death experience. If there is, the interesting thing is that even if there is an out-of-body experience which is associated with something which happened within that time of total brain death, then if psychedelics and endogenous psychedelics, which could have been released on the downturn of the brain at the beginning of that process, are released, and because they've been associated already with psi, including precognition, you know, I think there's some margin to still say that you could undermine the veracity of these veridical OBEs on the basis of saying that it was just precognitive, if that makes sense. You know, that if there's release of these chemicals to begin with, for whatever reason, there, you know, your mind is receiving information from what is going to happen some minutes in the future at the time when the brain is actually dead. I mean, that's just a kind of interesting thing to think of. But if you're taking all of these things seriously in one's theory, then that's another possibility. Yeah. I guess one last thing I might say about that is that the veridical stuff is often something we come back to because it's so compelling, etc. But I find some different things even more compelling, because with this it's very technical. But when it comes to, if you were to look at these experiences from a more subjective, more emotional perspective, when you have NDEs which are just so profound, just so transcendental. And I don't mean the kind of spiritual bypassing, you know, transcendental ego dissolution, mystical experience of being one with God, as wonderful as that is. You know, I'm talking about more interpersonal experiences of, you know, which so many NDEs are, you know, rich with, you know, in terms of having life reviews and becoming, you know, becoming consistent with everyone else that you've ever interacted with in the history of your life. You know, the depth of experience that's reanimated, the beauty of what it means to be alive at all, that you have this final insight into in the near-death state, you know, when it could be too late. And luckily those people come back and they are able to infuse their lives with this deep understanding of locking themselves in the context of where they are situated within the universe, you know, whatever the universe is, you know, and it's that level of profundity which I would like to have recourse to, you know, not just, oh, you know, wow, there could be some extrasensory perception going on, surely we've got to, you know, get rid of the neurocentric idea and think about things from a survivor's perspective. But it's this, yes, deep emotional, non-technical, like, evaluation or feeling of what these near-death experiences can actually mean, because ultimately we're human beings, and the thing which really sets us apart from anything else is meaning, and, you know, rich with meaning. And it's that, if anything, convinces me that there is more to life. Yeah.
Okay, brilliant. Sam, any last things you want to add?
Yeah, I certainly agree, and I actually appreciate that you're not really coming, although you are certainly open to this idea. I really do appreciate that you're a bit more objective than some of the people that I've discussed with, because a lot of these people are just very close-minded, and they say, no, there cannot be an afterlife, or there cannot be a mind separate from dudes, there cannot be mind separate from brain. That's it. And I have a lot of discussions with that, and recently I have very infuriating encounters with people, and I try to explain to them scientifically why, because these arguments have been going on for a long time about these near-death experiences. Firstly, it was, claimed that these experiences are just anecdotes, and then science came to accept them that, well, yeah, these things really do happen. And yeah, it certainly is the case that we do not know everything. We do not know much about near-death experiences. There are a lot of theories out there, and certainly one physiological cause is not going to apply to all of the cases. So if these experiences have a physiological basis, there's probably various factors influencing them. And we have to keep looking forward to this. We have to evaluate some of the evidence we have right now, because I think there are things that simply cannot really be explained away simply in terms of psychedelic experiences and things like that.